Okay, so we are going to do our Unit 1 review. I'm going to go through some of it with y'all. Okay, so that first question on your review is which transformations are rigid, and explain what rigid means. So, I'm going to explain what rigid means first. So what's another name for a rigid transformation? Anybody remember what it was? An isometry. That's another word for it. It's an isometry. So, with a rigid transformation, what do we know about the size and the shape? They always stay the same. So the size and the shape stay the same. Which means that the pre-image is congruent to the image. And out of our 4 transformations, 3 of them are rigid transformations. What's one of our rigid transformations? What's one of them?
Translation.
Translation.
Dilation. No, not dilation, because dilation changes, right?
Dilation changes the size, so that means that it is not a rigid motion. So what are my other 2? A reflection and
Transition.
rotation. Rotation. So those are my 3 forms of rigid motions. You can slide them, flip them, and spin them. So on your test, you're going to have to know what a rigid transformation is and what 3 types there are. So you have to know that. Okay, now on the second part right there, it says describe the following transformations in words and write a coordinate rule if possible. So on number 2, it already is in words, but what kind of transformation is that? It's a translation.
A dilation.
And then I need to write a coordinate rule for that.
6 plus 6 and 1 minus 4.
So I have X, Y arrow, so X, Y goes to X is going left 6. So is that
Negative.
plus 6 or minus 6?
Negative.
Minus 6. And then Y down 4, so is that plus or minus 4? Minus. So that is my coordinate rule for right when we have a translation. Number 3, it just says we have a scale factor of 3. So what type of transformation is happening there?
Dilation.
A dilation. And then I need to write a coordinate rule for it.
Which is K times X, Y.
So my scale factor is 3. So what am I doing to the X and the Y? I'm multiplying by 3, right? So that means my coordinate rule will be 3x, 3y. So just like I had kx, ky in my notes. It's 3x, 3y. So just multiplying everything by 3. Okay, now on the rest of those, we're going to look at their graphs and see what kind of transformation they are doing, and we're gonna write a rule for it if we can. So number 4, would that be a translation?
No.
No. Would it be a dilation? No, because it stays the same size. So is it a reflection or a rotation? Reflection. So if you see the coordinate and its prime line up, so I need to find what it's reflecting over. So I know I have a reflection, and wherever halfway between each coordinate is where it's reflecting over. So what is this line of reflection? X equals 2. It's on your x-axis at 2. So reflection over x equals 2. And is there a rule for that?
No.
There's no coordinate rule. Okay. Looking at number 5,
Rotation.
it is a rotation. So I rotated, and I'm going from my pre-image to my image.
90 degrees clockwise?
That's counterclockwise.
No, but you can. Oh, yeah.
You can do it.
Yeah, it
Yeah,
is.
but you can go 270 clockwise. It's
I didn't
90
see the little
counterclockwise,
thingies
270
on the-
clockwise. I'll try to
So it'll be 90 degrees counterclockwise or 270 clockwise. Either one of those is correct.
Wait, but. Never mind. Wait, but, there's only. I've been looking at that the whole time. Like, there's only. There's the 20. I'll just do some.
Okay, so we need a coordinate rule. So if you can't remember what, you can't remember the coordinate rule, you forget to look back at it and you think about this, you can always look at the 2 coordinates. So K starts off at 1, 2 and ends up at -2, 1. So what happens to the X and the Y? They flip.
So the Y switch. Or the X switch.
And then the new, or the old Y, new X, change signs. You could have also used the arrow rule, since it's counterclockwise, goes to the left, so the negative will be on the left.
So it's 90 clockwise. Oh, never mind. I see.
Okay? Looking at number 6, what do you think that one is? Translation. We need to write it in words and in a coordinate rule. So translation,
It's right one.
so I gotta start at my image and then go to my, I gotta start at my pre-image and go to my image. So I'm gonna look at Q and Q prime. So I go left or right?
Left.
Left, I'm going left 1. And then what am I doing?
Up to.
Up 2. So what's my coordinate rule for that?
It's X
X
minus 1.
Y plus 2.
X minus 1, Y plus 2. So for every X value, you subtract 1. Every Y value, you add 2. What do you think 7 is?
Rotation.
How far would it have rotated if it was a rotation though?
About 45 degrees.
We don't have that. So that can't be a rotation, so it has to be a
Inflation.
reflection.
How's that gonna be a translation?
It's line.
So I need to see what it's reflecting over, so I'm just gonna connect all my coordinates and go halfway between all of them.
X equals -2.
See where it crosses right here at -2 on the x-axis. So it's a reflection over x equals -2. And is there a rule for that?
Well,
Okay, number 8. What do we have there? Translation, rotation, dilation, translation, translation. I'm gonna start at, I'm gonna use T. So to get from T to T prime, I go 1, 2, 3, 4, 5, 6, 7. In what direction?
7, right?
7.
7, right, 5, up.
Yeah.
Ow. Shut up.
The right 7, up 5.
Your cat.
And then, what's my coordinate rule?
X plus 7, Y plus 5.
X plus 7, Y plus 5.
So, oh, never mind.
Number 9,
Translation.
translation.
Yeah, we were.
We were into the old fire room.
Okay, and then we need a coordinate rule. X, Y goes to, what's it gonna be?
X plus 3, Y.
X plus 3, Y minus 1.
Shut
What'd you
up.
say?
Good job, boy genius.
You heard me.
She's smart.
I guess so.
First thing wet.
How are you thinking?
Well, like, knowing you was probably like sarcasm. You're probably like, again. I like your cut, G.
Okay, number 10, what's that?
First thing wet.
That's a rotation.
Okay, so if it was a rotation, that would mean that D
We were easy.
would rotate right there.
No, it's a
Red
reflection over Y equals X.
Yeah.
So it's a reflection over Y equals X.
Good job, boy genius. Miss Lindsay.
Yeah,
Couldn't it be like a rotation of 90 degrees counterclockwise and then a reflection?
Bro, this dude corn. No.
You trying to go on that X?
That's what I'm saying, just do the right stuff.
yes, it could. That's called sequence of transformations that map the shape.
Please don't tell me we're gonna do that.
Okay, so we need our coordinate rule for that. Remember, when it's Y equals X, all you do is switch the Y and the X positions. So that it's in the same order, YX, YX.
Ew.
Okay, then number 11,
Reflection.
the reflection over what?
The Y axis. No, the Y axis.
Okay.
No, the X axis.
Dumb.
Duh. Hey, stop the meaning. I don't feel it, you know.
Okay, so it's a reflection over
Okay,
the
I'm sorry.
X-axis x-axis and our coordinate rule for that, if you can't remember it or don't have it, it starts at 1, 2, and ends up at 1, -2. So the x stayed the same and the y sign changed. On your test, I have it where you circle which type of transformation it is, and then you describe it in words and with a rule.
Dude, I didn't know there was a piece of corn inside of acorn.
Okay. Now number 12, it wants you to find the center of dilation and the scale factor. So if you had to find center of dilation, remember you just draw straight lines through the point and its prime. See where they all intersect. And for this one, where's my center?
0.
0, 0, the origin.
The origin.
Yeah. You're
And
good, man.
then if you want to find your scale factor, pick a point, any point. Which one you want me to do? L, K, or J? L.
L.
I heard L. So L is at -2, -4, and L prime ends up at -1, -2. So looking at that, you might be able to see what you're multiplying by. If you
2.
can't just see it, then you're gonna set up an equation. -2 times the scale factor gives you -1. Or you could do -4 times the scale factor gives you -2.
Divide, 1.
So I'm going to look at this one. I'm gonna divide both sides by -2. So what is my scale factor?
1/2.
1/2.
That's crazy.
Okay, so why isn't it a negative 1/2?
Because 2 negatives make a what, Ashton? What do 2 negatives make?
Positive.
Thank you.
And you should never have a negative scale factor. Because if you have a negative scale factor, it's like doing a dilation and a 180-degree rotation. Because it would change the signs of both, which is what the 180 does, and it would dilate it.
Oh, I see what you're saying now. Like, see, if I would have logged in yesterday when I was out, I would have like better understand this. Cause like I'm kind of.
Okay, so on number 13, it starts with the shape you're given, and it has our transformation is x, y goes to x -3, y + 2. What type of transformation is that?
Translation.
Translation. If you notice, all of these are going to be translations.
Yeah.
So you can do the coordinates where you subtract x from all, or subtract 3 from all the x's or add 2 to all the y's, or you could just do, you could use patty paper and trace it, or you can just count left 3, up 2. There's my R prime. Left 3, up 2. There's your S prime. And do that with all of them. So, right 3, up 2. Right 3, up 2. Yeah, I can't tell my left and my right.
I can't even.
I'm moving left, but I'm saying right. Okay.
Wait, what?
Bruh.
Oh, you just messed me up. I corrected it wrong. You're saying right.
I know.
We should do it.
I was moving left on my graph.
I was going with you too. I'll say one, bro.
Oh, I was saying right in my brain, but I went left.
What you gonna do?
I don't know why I put an R down here either. Of these three. Let's leave these off. Okay, so then down at the bottom of those, right there, it wants you to put the coordinates for your new point. So what are my coordinates for R prime?
-2, 1.
S prime?
0, 2.
You know what?
0, 1. T prime?
-3, -1.
1. It's
What?
one negative one.
Wrong.
I'm sorry, what?
Why we pay?
Oh, I put you, my bad, I'm like you, okay.
And then U is at,
-3, -1.
Let's hear if we can do it again.
It's you.
okay, now on number 14, we're going left 11, up 4. Again, you can write out the coordinates, find D, E, G, and F.
That is a strong message. Great. Since I wasn't
So
here.
you could write out the coordinates like I just did, and then subtract 11 from all the X's and add 4 to all the Y's, which is what I'm gonna do for this one. So 6 minus 11 is -5. 8 minus 11 is -3. F, so 5 minus 11 is -6, and 3 minus 11 is -8. And then add 4 to all my Y's, so 5, 4, -2, -1.
Wait a minute.
So I found all my coordinates first. Again, you can do the counting method. I'm gonna go and see if my coordinates are right using the counting method. So there's D prime, and it is at 1, 2, 3, 4, 5, -5, 1, 2, 3, 4, 5, 5, where it should have been. Again, you can use counting method, you can use the adding subtracting method, or you could use patty paper, whereas you just, with the patty paper, you trace it and do the transformation one time, the counting method one time, line it up, and you can find your other point. Okay. So number 15 is the rules for reflections and rotations. So this is what you're gonna be given on your test. That exact stuff right there is exactly what it's gonna look like on your test and what you have to fill out for part of your grade. So that stuff on the board won't be up there, okay? So for an x-axis and a y-axis rotation or reflection, remember x and y stay in the same spot, but you're gonna change the sign of one of them. Since this is x-axis, or what are we changing, the sign of the x or the y?
The X.
Nope.
I mean,
Y.
Y.
Y-axis, we change the sign of the x. It's always the opposite. If x change the y, if it's y change the x. Reflection. And then with a y equals x, remember we put it in that order, y x. And when it's y equals negative x, put it in that order with both of them negative. Okay, then with 90 degrees, we always switch the x and the y. And then to find out which one's negative, clockwise goes to the right, so our negative goes to the right. We'll have y negative x. On counterclockwise, that goes to the left, so our negative goes to the left. So negative y x. And then on 180, all you do is change their signs. So that right there is on your test. That's the first thing I give you. You have to fill that out, and then you go on to the next part.
We doing a test on paper? Oh, we doing a test on paper, please. Use the test paper.
Okay, so next we've got our reflections. So looking at number 16, I want to reflect over y equals negative x. So I know that xy is going to go to negative y, negative x. I'm going to write out my original coordinates because that helps me. So A starts off at 0, 4. B is at negative 2, 3. And C is at negative 1, 1. So I write out my original coordinates when I'm using the coordinate rule, like the negative y, negative x, so I can see what I'm actually flipping. Again, if you're using patty paper, you don't have to do all of that part. You can just actually flip it with the patty paper. So, looking at A, where's A prime going to be? Negative 4, 0. I switched their positions and changed both signs. So A prime is at negative 4, 0. Where's B prime going to be?
Negative 32.
Negative 3, positive 2. And then C prime,
Negative 1 positive.
negative 1, positive 1. It actually ends up at the same spot because it's on the line of reflection. Okay, the next one we're reflecting over the y-axis. If you want to use the coordinate rule, it's x, y goes to negative x, y. Remember, change the x because it's on the y. So you can do the counting method, or you can do the coordinate rule. So I'm flipping over this axis, the y. So G is 1 to the left, G prime is 1 to the right. F is 7 to the left, F prime's 7 to the right. H is 5 to the left, H prime's 5 to the right. And again, you could have done the coordinate rules. So F's at 7, negative 2, G's at 1, negative 4, and and H is at 5, -5.
H is at what?
7, -2. Okay, on number 18, reflect over y equals x. So I'm just gonna take my x and my y, and I'm going to flip them so that they're in at yx position. So I wrote out all of my original coordinates. Again, you can use patty paper. If you don't have to write out the coordinates like I do, because I'm visual, I have to be able to see it, then, you don't have to write out that stuff. So I'm going to flip x and y, so q prime is at -1, 4. Where's r prime? Where's s prime?
-6, 2.
-8. T is at
You're doing them in
-2.
different order.
I'm following the stuff at the bottom.
No, I keep doing it.
Mhm. And make sure you're putting your coordinates in the correct blanks down at the bottom, because if you mix them up, they get marked wrong.
Who's Bush?
So number 19, we are going to reflect over y equals -2. I'm gonna go in and draw a dotted line at y equals -2. So I'm gonna go on my, or y equals +2, not -2. Yes, do you have a question? Malia? No. So I'm gonna go on my y-axis to 2. I'm going to draw my horizontal line for y equals 2. And then I'm going to reflect over that. O is one above, O prime goes one below. So O prime is at -2, 1. N is 3 above, N prime will be 3 below. And that's at 1, -1. And remember, you're reflecting off of that dotted line, but that's not your new axis. You still go off your main axes, the x and y, to count your coordinates. Okay, M is 1, 2, 3, 4, 5, 6 above, so it'll be 6 below. 1.
-1, -4.
It is at -1, -4. Then L is 4 above, L prime is 4 below. And that's at -4, -2. Okay, number 20 wants you to reflect over the x-axis. That rule is x, y. Goes to x negative y. You can do the counting rule or you can do the coordinates. So A is 2 below, A prime will be 2 above. B is 3 below, so B prime is 3 above. C is 7 below, C prime is 7 above. And D is 6 below, so D prime is 6 above. And then I need to go find my coordinates for those. So A is at negative 3, 2. Where's B prime?
Oh,
1,
1, 3.
3. C prime is at 2,
7,
7, and C prime is at
negative 2, 6.
negative 2, 6. And then the last one for reflection, we're going to reflect over x equals negative 4. So you're going to go on your x-axis, go to negative 4, and that up and down.
Good job.
Hey, there's a trash can there. I'm going to go to x equals negative 4, and I'm drawing a vertical dotted line. And that is what I will reflect over. So x is 1, 2, 3, 4 to the left. X prime will be 4 to the right. So x prime is at 0, 3. Y is 2 to the left. Y prime, 2 to the right. And that's at negative 2, positive 5. Z is 1 to the left, Z prime is 1 to the right. So Z prime is at negative 3, negative 2.
Looks like we're all done.
That section.
Take us some pie paper.
Yeah, it's up there on the plane. Okay, next section, we're looking at rotations. So again, with rotations, you can use patty paper or you can use the coordinate rules. Coordinate rule for 90 degrees clockwise. The x, y goes to switch your y and your x. This is clockwise, it goes to the right, so the x is now negative.
I'm gonna be able to use this paper tomorrow.
Yep.
Okay. I bet.
So, L is at 3, negative 2. L prime,
Wait, what
switch them.
What paper?
Patty paper. So switch them and change the sign of the original x. So L prime is at negative 2, negative 3. M prime, switch them, change the sign of the original X. So M prime's at -5, -1. I rotated 90 degrees clockwise.
You didn't do it right.
What's easier to you?
What?
Right, which way to do it?
What are you talking about, patty paper or?
Patty paper is doing like that.
In my opinion, patty paper's the easiest way to do it. It's little to no having to think about it. You either turn it, flip it, or
Don't
slide it. Okay, now 23, I want you to rotate 270 clockwise, which is the same as 90 degrees counterclockwise. Remember, I like to go back to the 90 one so I can find my rule. So X, Y goes to switch Y and X, clockwise goes to the left, so the Y becomes negative.
Dang. How do you know which one is D and which one is E though?
Huh?
How do you know which one is D and which one is E though?
Says D.
Saying, if you don't write it on the paper.
Look on the board.
I know, never mind. Whatever.
I labeled them, that's why I put D, 1, 2,
All you
3,
gotta do is
4,
relay
4.
them too.
Oh, if you're doing it on patty paper, literally trace it and put D, E. Okay, so I'm going to flip those and change the sign of the original Y. So what is my D prime?
-2,
-2, +1.
1.
And then what's E prime?
-4, +1.
-4 or +4?
Positive.
So I went three quadrants clockwise, 1 quadrant counterclockwise. So that is rotation. Now we're gonna look at dilation.
Oh my goodness.
Oh.
So it's fine.
Can we use the pad and throw dilation too?
How would you do that?
It only patty paper only works for rigid.
You just gotta fold your paper over.
Okay. So with dilations, again, I like to write out the coordinates. So I'm gonna write out G, H, and I. G is at -2, 2. H is at 4, 4. And I is at 4, -2. So, what's my scale factor that I've been given?
1/2.
So am I reducing or enlarging the shape?
Reducing.
Reducing, which means it's gonna get smaller. So it's gonna be half the size. So what's half of -2?
1.
-1, half of 2 is 1. So G prime is at -1, 1. What's half of 4?
2.
2. So H prime is at 2, 2. And then I prime is at 2, -1.
And if you graph that, that is significantly smaller.
So,
What does the center part mean? What does that mean?
The center,
Yeah, like,
so you can actually dilate around any point on the graph. And it just kind of it doesn't change the size, it's just changing where it's actually at on
so
the graph.
what's this one?
That one's dilated around the center. But if you dilate around a point other than the origin, you have to translate it from that point of origin from the point of rotation to the origin, dilate it, translate it back to the point or the center of rotation or dilation. That's why we get into the units. Rotations around a point are easy because you literally just rotate your patty paper around that point. But dilations around a point, a little bit harder, a little bit more work.
This one, the next one, that's the negative positive one.
Oh, this is the X and Y axis. Yeah. They're just in a different spot on this graph. But the X and Y axis is still right here. So there's my original coordinates. Then I'm just gonna take them and multiply them all by 2. So what's negative 7 times 2?
Negative 14.
And 1 times 2? 2. So I'm gonna go to negative 14, 2 to graph that. There's my A prime.
This is a big triangle.
B prime, I'm going to multiply negative 5 times 2 and 6 times 2.
Negative 12.
Negative 10, 12.
Okay. That thing is huge.
And then C prime,
Negative 2.
negative 2, 4.
Negative 2, 4.
How did you even, did you find 10, 12, 10, 12 off of the regular B?
Huh?
Did you find 10 and 12 off of the regular B, like number B? So then how do you know like where to mark B comma? Oh, it's gonna be negative 10, 12. Oh, anyway.
I'm sorry, what? Where do you think you're going, dude?
To the ranch room?
No.
Okay. Then those last 2, you're doing a sequence of transformations. So you'll graph the original and then do
Is this
the
extra
2
credit?
transformations. What?
Is it extra credit?
No. Not hard.
Yes, it is. So we had to graph the original triangle.
So on 26, I'm gonna graph the original. So negative 2, 0, 0, negative 1, negative 3, negative 2.
$90 CCW. Ladies and gentlemen, get your patty paper.
Okay, so for my first transformation, I am doing a 90-degree counterclockwise rotation, which means that I switch Y and X. Since it's counterclockwise, it goes to the left, so the Y is negative.
Wait,
What? I waited. What? What did you say?
it's cause, never mind.
So I just rewrote my coordinates down there with M, N, and P so that I could write it out in a straight line. I'm sure it'll work. But I'm going to rotate, so I'm switching the coordinates, changing the sign of the Y. So M prime is at 0, -2. N prime is at +1, 0. And P prime is at +2, -3. And remember, you don't have to graph the middle one. You can if you want to, but you don't have to. And then the last thing is you're going to dilate with a scale factor of 3. So I'm going to multiply all those coordinates by 3. And I'm going to go ahead and put them in the blank down at the bottom when I multiply by 3. So 0 times 3 is 0. What's -2 times 3? -6. 1 times 3 is 3. 0 times 3 is 0. 2 times 3 is 6. And what's -3 times 3? -9. So there's my coordinates of my final image.
That's crazy.
So, on your test, if I give you a blank graph, or a graph with just one shape, I'm expecting you to graph it. If I give you the blanks for the coordinates, I'm expecting you to put the coordinates in the blank. Okay? When you get your test tomorrow, read the directions first off. But don't come ask me if there's a graph, if you're supposed to graph it. People love to do that, and I don't know why. Okay? So, for number 27, I'm going to go ahead and plot my original point.
Bruh. No, because you're going to be gone.
Okay? Then for the translation part, you can do it with the county, or you can write out the coordinates, again, up to you. So I'm just gonna move everything left 8, down 3.
We don't have visuals. Yeah. Over.
Okay, so there's my first transformation. Then I'm gonna reflect in the x-axis, which means I'm just gonna flip it up over the x-axis. And I'm gonna do that by counting. D's 3 below, new D primes 3 above, D prime 6 below, new D prime is 6 above. E prime is 1 below, new E prime is 1 above. And F prime is 4 below, so new F prime is 4 above. Again, do it whichever way makes sense, the most sense to you. Then I'm gonna fill in my new coordinates, the D, E, F, and G prime. Okay, when you finish with the review, copying it down, if you don't have any questions, you need to work on your daily grade 6, which is in your unit packet. Page 7, 8, 13, 14, 19, 20, 24, 25, 30, and 31. If you are already finished with it, you can take those 5 pages out, and I'll step them together and we can turn them in. If not, they are due tomorrow. Yeah.
Are you saying like I might have to have homework?
Well, I've given you time in class to do them.
No, we went over this other day. Which one? I'm missing. I finished all of them. What's the most recent one we did? Like, we did one yesterday?
We did 2 of them yesterday.
Like a front and back?
So,
No.
Oh, let me go.
we've done page 7, which is that page. Page 8, which is this page.
I don't know.
13, 14,
Yeah.
19,
Done that.
20.
Done that.
This is what we did yesterday.
I ain't done that.
This is what we did yesterday. Goes up, and then we did 30 and 31. And I am gonna post those on Google Classroom.